Hi, this is Harikrishna. Welcome back. In this video, we are going to discuss about F distribution. F test is used to verify whether the two population variances are same or not, or if the two samples came from the same population or not. In this test, the null hypothesis is sigma 1 square equals to sigma 2 square or s1 square equals to s2 square. That is, the population variances are same. The test statistic is f equals to s1 square divided by s2 square when s1 square is greater than s2 square, or we take f equals to s2 square divided by s1 square if s2 square is greater than s1 square. Here we have two different cases. First case is if we are not given the variances s1 square and s2 square, then the population variances are given by the formula capital S1 square equals to summation xi minus x bar whole square divided by n1 minus 1 and s2 square equals to summation yi minus y bar whole square divided by n2 minus 1, where xi is the first sample data, x bar is the mean of that sample and size n1. Similarly, yi is the second sample data, y bar is the mean of the second sample, n2 is the size of the second sample. Now the second case is if we are given the variances s1 square and s2 square of two samples of sizes n1 and n2 respectively, then the population variances are given by the formula s1 square equals to n1 s1 square by n1 minus 1 and s2 square equals to n2 s2 square by n2 minus 1. That is, if we are not given the variances of the samples, then we evaluate the population variances by using these two formulae. If we are given the sample variances s1 square and s2 square, then we use these two formulae to evaluate the population variances, and then the test statistic is f equals to greater variance divided by smaller variance. Here the degree of freedom is v equals to v1 comma v2, that is n1 minus 1 comma n2 minus 1. Now the important properties of F distribution are: number 1, F distribution is free from population parameter and depends upon degree of freedom only. F distribution curve lies entirely in the first quadrant. Third property is F distribution curve depends not only on the two parameters v1 and v2, that is degree of freedom, but also on the order in which they stated. Now coming to the example problem, here we have two independent samples of 8 and 7 items respectively had the following values of the variables. Sample 1 9, 11, 13, 11, 16, 10, 12, 14. Sample 2 11, 13, 11, 14, 10, 8, 10. The question is, do these estimates of the population variances differ significantly? That is, we have to evaluate there is any significant difference between two population variances. So we have to use the F distribution or F test. Given size of the samples n1 8, n2 7. Here only given the sample data. So the case is if we are not given the variances s1 square and s2 square of the samples, we have to evaluate population variances by using these two formulae. So in our problem, just given data of the samples, so we have to evaluate variances s1 square, s2 square by using the formulae s1 square equals to 1 by n1 minus 1 into summation xi minus x bar whole square and s2 square equals to 1 by n2 minus 1 into summation yi minus y bar whole square. With the help of this table, we can evaluate them. Now taking the first sample data x and x minus x bar, where x bar is the mean of the first sample, that can be evaluated by using this formula x bar equals to 1 by n into summation x, that equals to 12, that is sum of all these values divided by the size of the sample. X minus x bar is x is 9 minus x bar 12, that is minus 3. Similarly 11 minus 12 minus 1 and so on. Now taking the squares of these differences, x minus x bar whole square, these are the squares of the differences. Now the formula for variance is s1 square equals to 1 by n1 minus 1 into summation x minus x bar whole square. Evaluating the sum and divided by with the degree of freedom v1 or n1 minus 1, that gives 5.14. Similarly for the second sample, evaluating y, the given data, and y bar is the mean of the second sample, 1 by n2 into summation y, the sum of all these values divided by size of the sample, that gives 11. And then evaluating the differences y minus y bar, that is 11 minus 11 0, 13 minus 11 2 and so on. And then evaluating the squares of the differences, that gives 0 4 0 9 1 9 1, and the sum of all these values summation y minus y bar whole square divided by n2 minus 1, that gives 4, that is the variance of the second population. So by using the formula s1 square equals to 1 by n1 minus 1 into summation x minus x bar whole square, s2 square equals to 1 by n2 minus 1 into summation y minus y bar whole square, we get the values 5.14 and 4. Now coming to the testing hypothesis, in F distribution, the null hypothesis is defined as h naught equals to sigma 1 square equals to sigma 2 square. That is, there is no significant difference between two populations, or the two samples came from the same population. Alternative hypothesis is complement of this, that is h1 such that sigma 1 square not equal to sigma 2 square. Now the level of significance is not mentioned in the problem, so we assume that alpha equals to 5%, that is 0.05. Now the test statistic is f equals to greater variance divided by smaller variance. Now here we observe s1 square is the greater value, so s1 square divided by s2 square, that equals to 5.14 divided by 4, that equals 1.285. Now coming to the tabulated value, for the given level of significance alpha equals to 5%, with the degree of freedom v equals to v1 comma v2, that is 7 comma 6. From F distribution table, we can find F tab equals to 4.21. Now coming to the conclusion, clearly here Fcal is less than Ftab. Fcal is 1.285, Ftab is 4.21. So Fcal is less than Ftab. Therefore, the null hypothesis has to be accepted at the given level of significance. That is, there is no significant difference between two variances. That means the two samples came from the same population. Coming to the next example problem. Here, pumpkins were grown under two experimental conditions. Two random samples of 11 and 9 pumpkins show the sample standard deviations of their weights as 0.8 and 0.5 respectively. Assuming that the weights of the distributions are normal, test the hypothesis that the true variances are equal. Now, clearly in this problem, given that the two samples of sizes n1 equals to 11 and n2 equals to 9, the standard deviations are s1 square equals to, standard deviation, that is s1 0.8 and s2 0.5. So variance is s1 square and standard deviation is s1. Now given standard deviations 0.8 and 0.5 respectively, we have to check whether there is any significant difference between population variances. So this is the F test. Now coming to the solution, given the size of the samples are n1 equals to 11, n2 equals to 9, and standard deviation of the first sample is 0.8 and standard deviation of the second sample is 0.5. Clearly here sample standard deviations are given, so this is case 2. If we are given the variances of samples, then we can evaluate the population variances by using these two formulae. So in this problem, given S1 equals to 0.8 and S2 equals to 0.5, therefore the population variances S1 square equals to N1 S1 square by N1 minus 1, that equals to 11 into 0.8 whole square by 10, that gives 0.704, and S2 square equals to N2 S2 square by N2 minus 1, that equals to 9 into 0.5 whole square divided by 8, that equals to 0.281. Now the test statistic is null hypothesis. Let the null hypothesis be H0 equals to sigma 1 square equals to sigma 2 square. That is, there is no significant difference between two population variances. Alternative hypothesis is the complement of the null hypothesis that says that H1 says that sigma 1 square not equal to sigma 2 square. Now coming to the level of significance, not given, so assume alpha equals to 5%, that equals to 0.05. The testing hypothesis, test statistic F-cal. The test statistic is F equals to greater variance divided by smaller variance. Now in these two values, if you observe 0.704, that is S1 square is the greater than S2 square. So F-cal equals to S1 square divided by S2 square, that equals to 0.704 divided by 40.281. That gives 2.5, where S1 square is greater than S2 square. Now the tabulated value at the level of significance alpha equals to 5% with the degree of freedom V1, V2, that is N1 minus 1, N2 minus 1, 10, 8. From F distribution table, F tab equals to 3.35. Now coming to the conclusion, if you observe clearly F cal 2.5, which is less than F tab 3.35. F cal is less than F tab, therefore the null hypothesis has to be accepted at the given level of significance. That is, there is no significant difference between variances. Now these are the practice problems. We will continue in the next video.